Welcome to this video. We're going to learn about projectiles. Now, we've dealt with objects that you drop and they fall straight down. A projectile is similar, except instead of climbing all the way up to this building, or maybe this is just a table and this is a pea sitting on the dinner table, instead of just dropping it straight down, you flick it at an angle. This causes the object to go up and then back down. And here it is in the very final moment, just before it strikes the ground. Now, while it's in the air, after you flicked that dinner pea, once it's in the air, the only thing that pulls on it is gravity. And so it is in free fall. Now, we want to analyze the motion. We want to analyze the motion of this projectile. But it's along two dimensions, right? It's going up and down, but it's also going to the right. X and Y axes. Every time in this unit we've encountered two-dimensional motion, what did we do? We used components. So take this velocity vector and break it into components. It's launched with some horizontal velocity, and the P is launched with some vertical velocity. So the question is, what's happening to these two velocities, the horizontal and vertical, as the P travels in the air? We're going to start by thinking about free fall, right? I mean, free fall, what do we know about free fall? Well, we know gravity accelerates objects downward. Gravity doesn't pull left or right. And we know more than just which way gravity pulls. We know the acceleration due to gravity. Okay, the acceleration in the y direction, that's up-down. Well, what did we just say? Okay, well first, acceleration is change in velocity over change in time. So if we deal with just the y velocity, just this purple line pointing up, how does that velocity change over time? Let's think about this. Well, the acceleration due to gravity is negative 9.81 meters per second every second. So you see this arrow, this vertical arrow? Every 1 second, we subtract 9.81 meters per second from that velocity vector. And on the x-axis, what's happening? Well, the only thing that acts, the only thing that pulls is gravity, right? And gravity pulls which way? Oh, gravity pulls down, so nothing is pulling in the x direction. The acceleration equation is change in velocity over time. We're applying it to the x-axis. But we just said that every second, there is no change in the x velocity. The delta, see that delta right there? That means change. And there is no change. We don't add anything, and we do not subtract anything to the x velocity. So what does that mean? This x arrow, this x velocity, is the same at all moments in time. The object never speeds up or slows down on the x-axis. It's always moving forward at the same speed. The y velocity, that's a different story. There is y acceleration. So you're going up, but the vertical velocity here, it slows down. The arrows get shorter. The velocity decreases. And then at the top, you actually stop to change directions. And on your way back down, you speed up. And the vertical velocity grows in the negative direction. Now we can take these velocities, right? We said these vx's, the x velocities, those are all the same at every moment. The y velocities, though, they decrease, and at the top, look at this, there is no y arrow at all. We're not going up or down, so that velocity is 0. The vertical velocity is 0 at the top. And then we increase on the way down, increase the speed. We can take this, these two vectors, the components, and we can construct the two-dimensional vector once more. So we break into the components, and then at the end, after we deal with components, we put the components back together to get a 2D velocity. Here, the 2D velocity is like this. This is the velocity vector, the whole thing. In this moment, there's the vector, here's the velocity, there's the total 2D velocity, here and right there, in the very final moment, right before it hits the ground. Sometimes we'll consider the entire segment from the beginning to the very, very end. In that case, this velocity is the initial velocity, and this velocity down here is the final velocity. Other times we'll consider just half of the trip. This will be the initial velocity in the beginning, and the final velocity will be just this value, the x-axis velocity, at the end. Sometimes we consider from the middle to the very end, making this our initial velocity, and this down here our final velocity. This is all called, this example, the one we've just drawn, this projectile was launched at an angle, because when we sent it off, it was going up and horizontally. What's the other alternative, the other option? Instead of launching at an angle, we can launch something horizontally. So here you are, you take your P, and you just flick it straight to the right. What happens? It does this. And I've shown it here in the very final moment of freefall, right before it hits the ground. Okay, then now, let's see, the horizontal velocity, the x velocity. Does this x velocity change as we go? No, because gravity doesn't pull left or right. It can't speed up or slow down horizontally, because nothing is pulling it. Alright, and what about the vertical velocity? Well, we didn't give it a downward or upward kick at the beginning, so right here it's not going up or down. But as it goes down, it speeds up. So those velocity vectors, they grow longer and longer in length, showing an increasing magnitude. The x velocities again, those x velocities are unchanged. The y velocity starts at 0 because there's no arrow pointing up or down. And as time passes, that y velocity grows, in the negative direction, of course. We can draw the 2D velocity again, and you see that the direction is always changing. The direction of the 2D velocity vector is changing. And in most cases, this will be our initial velocity, and this right here will be our final velocity. Now, what do you notice about the initial velocity? It's different here from the final velocity in a particular aspect. When you launch a projectile horizontally, VI, is this one-dimensional or two-dimensional? VF, is this one-dimensional or two-dimensional? When launched horizontally, VI is one-dimensional.